So here we will understand how this machine cycle or the different type of operations performed by the microprocessor is related with the T state. So as I had explained earlier also, these are the frequent operation listed here in this table as opcode fetch operation, memory read operation, memory write operation, IO read operation, IO write operation. These five operations are more frequent with respect to microprocessor accessing outside to the world. So here, how many T state is required for these kind of different operations, or these are called as a machine cycle also. So for opcode fetch operation, the minimum number of T state required is 4 T state, and maximum number it is required here as a 6 T state. So here minimum will be 4 T state and maximum will be 6 T state. So how it is 4 or 6, that we will learn more about this thing into the instruction set. But as of now, we need to remember that for opcode fetch operation, we need that microprocessor need minimum of 4 T state or maximum of 6 T state to perform this operation. Similarly, for memory read operation, this microprocessor will take 3 T state, and we'll get some logical answer here that why this opcode fetch is required some more T state compared to memory read, even though both are memory reading operation only. So this both opcode fetch, memory read, these both are memory related operation. It means it is reading the data from the memory. But in the case of opcode fetch, why it is required some more time here? The reason behind that, for example, let's say this is having MVI B, 7FH. So here this MVI B is called here as a opcode, and this 7FH is called here as a operand, and this is stored in memory at some location. Let's say here this is having 2000H. At this 2000H we have the opcode for this MVIB as like XXH. So this is stored here as XXH, and at 2001 it is stored here as a 7FH. So whenever this microprocessor is going to execute this instruction as a MVI B, 7FH, then by that time, first of all, it will fetch the opcode from the memory, and here opcode is having the data, or this is having the code which is giving the instruction to the processor what kind of operation have to perform. So decoding and execution of that part means I'm trying to say it here in this opcode fetch operation, the last T state is required. The last T state is required for the decoding and execution of this opcode. But here in the case of memory read, once processor is knowing what operation has to perform, then in the second cycle of the operation it is going to read this data only. So this both is having reading operation only, but the difference here is this is giving the instruction to the processor what kind of operation has to perform, and followed by this 8-bit of the data as a 7FH. So for reading operation of 7FH and XXH, it is taking same time period as a 3 clock period, and fourth T state or fourth clock period is required by this XXH for decoding and execution of the instruction. So that is the reason we can answer that logical things that why opcode fetch is required more T state compared to this memory read, because opcode fetch is having the fourth T state, or in the fourth clock period it is having decoding as well as the execution of that instruction, followed by their data as a operand as a 7FH. So simply have to read this data as a 7FH. So that is the reason for opcode fetch it is required more time compared to this memory read. Similarly, as like memory read, for the memory write also it is required only 3 T state. This we can understand in better clarity in the timing diagram of the opcode fetch, memory read, memory write. Similarly, for the IO read also, it is required only 3 T state. It is required only 3 T state, because this is very similar as like reading operation of this 7FH. So for IO read, just microprocessor is reading the status of their input port. So that is the reason it is also required only 3 T state. There is no decoding or execution part in this IO read operation. So that is the reason it is taking 3 T state, and their similarity is as like memory read. Similarly, for IO write also it is taking only 3 T state. It is very similar to this IO read, but in this IO write, what the processor is doing, whatever is as per the program instruction, whatever they want to update output port, so that output port will be updated by this IO write operation performed by the microprocessor. So here we had seen there is only two data in this table. One is for opcode fetch operation, so that will be more frequent, like instruction is required only 4T state, and some of the instruction is required 6T state, so that we will learn further. So there is only two data for opcode fetch operation, minimum 4, maximum 6T state, and for rest of the operation, whether it is memory read or memory write or IO read or IO write, it is required only 3T state. These all the data is required whenever we are going to analyze the program to find out their overall execution time. So you need to remember about this, and then we can easily find out the execution time of any instruction by knowing this table. So I hope you understand the relation about this machine cycle with the T state or the different type of operation, how it is performed with respect to this T state or clock period.